I would like to share with you a personal story. 10 months ago, I was leaving my previous job to join Grafana Labs and focus on Cortex development. Before that, I've never contributed much to open source. And I feel I've learned a lot over the past few months. And the most important lesson I learned about open source is that open source is not about technology. And actually, open source is all about people. And to me personally, open source is one of the most beautiful expressions of collaboration. Think about it, a group of very diverse people coming from all over the world, working together on a single project and giving back this project to a wider community. And in this talk, we would like to share with you the story behind a stronger collaboration between Cortex and Thanos. Hi everyone, my name is Marco. I'm a software engineer at Grafana Labs. I'm a Cortex maintainer and I'm recently joined the Thanos maintainers as well.
Thanks, Marco. So my name is Bartłomiej Płotka and I'm a software engineer at Red Hat in the monitoring team. I'm part of the Prometheus team as well and co-author of Thanos project. I also, you might know me from the newly created CNCF Seek Observability, which you can find on more details on our repo. Please join us. So today we will be kind of continuing the talk that we made with Tom Wilkie, who is co-author of Cortex, nearly a year ago, on the PromCon in Munich last year. And we're talking about those two projects. We introduced them and we talked about the differences and similarities around those. And as you maybe know, those projects aims for kind of the same goal, which is global view of your metrics, of your Prometheus metrics, maybe durable view, so you can also handle some kind of HA of replicas of Prometheuses, and last but not the least, long-term storage retention. So during this talk, we'll continue on this base. However, let's briefly talk what we mentioned during that talk. You can rewatch this talk from the last year for more details. And essentially the TLDR is that in the beginning, especially in the beginning, those projects were different on those kind of three simplified dimensions. Cortex was mainly push-based, where you were configuring Prometheus to push the data to some centralized clusters, versus in Thanos, you are rather pulling the data and querying directly from the Prometheuses. Cortex aimed for different databases, so NoSQL for index and object storage for compressed chunks. In terms of Thanos, we aimed for kind of simplicity and having very cheap storage. So we store everything in object storage, and we store everything in the TSDB format versus Cortex. We're storing in kind of custom index because of those separation in databases. However, we have many, many similarities, and I won't be reading all of them. You can kind of read them on your own, but the message is clear. We definitely have more in common than in different.
And over the time, Cortex proved to scale very well, and at the same time offer very good query performances. But at the same time was perceived as a complex system. And I remember a famous discussion on Twitter about this specific Cortex architecture diagram. And to be honest, the first time I've seen this diagram, I was scared as well. So while Cortex was perceived as a complex system, at the same time, Thanos was emerging and gaining popularity as an easier way to scale out Prometheus. And in the Cortex community, we learned a lot from this sort of soft competition with Thanos. And this was a trigger to improve the Cortex user experience as well. We did many things that improved the Cortex UX, but to give you a few examples, we have introduced a schedule for the release process. We worked hard on a user-friendly documentation, which we also published to a website. We worked to reduce the dependencies required to run Cortex. Like, for example, we introduced Gossip to share the state of the hash ring, which is a distributed data structure we use for sharding and replication. So basically, Gossip, when you use Gossip, you don't need console as a backend storage for the hash ring. And then we worked to introduce the single binary mode. So nowadays, you can run Cortex either in microservices mode or in single binary mode. And when you run Cortex in the single binary mode, what you actually get is a single binary with a single configuration, which you deploy as a single deployment group, like, for example, a single deployment set on Kubernetes. And then you just scale up or down your Cortex cluster, changing the number of replicas of your Cortex nodes. And then we started brainstorming about whether we can completely remove the NoSQL index store dependency. And while we were still in the brainstorming phase, a PR from the community popped out of the blue, and specifically was a PR from Thor Hansen, where he was proposing an experiment to introduce an alternative storage engine into Cortex, which we later called the Cortex block storage, which was using Prometheus TSDB blocks to store the time series data instead of the custom index stored on the NoSQL database plus chunks stored on the object store. And in this experiment, Thor was using specific components of Thanos to build this alternative storage engine. And yeah, we found it brilliant. And we actually realized that what we wanted to do was something Thanos already did. So instead of competing with Thanos, why not teaming up with Thanos and build something together? So why not collaborate over compete as an alternative solution to scale out Prometheus and have a long-term storage for your time series data?
Meanwhile, on the Thanos side, we were focusing on stabilizing our components, making sure they are reliable, and we were at the point that functionally we were solid. We had kind of simple architecture, very gradual form of integration with Prometheus, with kind of multiple optional steps that were kind of easy to do. However, with more adoption, clearly more kind of edge use cases came in. And for example, you can imagine that in this model of query fetching the data directly from Prometheus, you might hit some problems where the cluster and the centralized cluster where the queries and where the user is, and the clusters where you're collecting the metrics from are maybe far away geographically via some firewalls and some overhead. What if there is no possibility for ingress traffic for those clusters? What if those clusters are totally isolated from any kind of modification, advanced modifications like adding a Thanos sidecar? Or last but not the least, what if you have kind of ephemeral cluster that you want to spin up only for a short time? And in this case, the method of lazily upload the blocks into the object storage is not perfect because you don't have 2 hours to wait, or maybe you don't want to play with kind of advanced flashing mechanism. So this is where we looked on the Cortex side on our kind of initial, let's say, competitor, and we saw the kind of push mechanism, right? That's why this definitely inspired us in some way to create a Thanos component called receiver, which allows exactly that in a kind of similar fashion, where you can kind of configure Prometheus with your remote write to push into those receiver components. However, while functionally we were solid thanks to that improvement that we kind of learned from Cortex, we are definitely looking on other stuff. Particularly, Cortex is known from their focus on performance, and literally, performance in very, very good point of view, because literally a Cortex solution has internal kind of focus and SLA on making latency very, very, very kind of low. And it means maybe even, whatever query you do, it should be super fast in terms of seconds. And we were definitely jealous on Thanos' side. And we were thinking how to embrace those improvements Cortex did. And this is where a year ago, Tom kind of shown on Prometheus London meetup we organized together. And like he extended Cortex query frontend to work on Thanos backend as well. And this kind of changed the state of the art and our approach towards those two projects together, because we've seen that Cortex team is very eager to reshape their component to allow reuse and allow collaboration, and that this immediately improved Thanos world performance-wise, because we could cache responses, but it gives also the potential for other improvements and other collaboration. And this is from Thanos side the critical point where the kind of competition changed into the collaboration.
But collaboration is a two-way street and requires an effort on both sides. So when building, for example, the Cortex block storage, on one side, when Cortex contributes with some changes into Thanos, we have to make sure to not bring any negative impact on Thanos, like in terms of performances or maintenance burden. But at the same time, the Thanos community is somewhat required to be open, to discuss and eventually accept changes which are not strictly beneficial to Thanos, like, for example, refactorings, to ease the integration of their own components into Cortex itself. And let's be honest, sometimes it's tough, the collaboration. Sometimes requires reaching a consensus among a wider group of people. Sometimes we have to do changes into Thanos first, get them merged, and then backport those changes into Cortex. And it's very, very tempting to pick the shorter path. It's very tempting to maybe fork a single package directly into Cortex so that we don't have to discuss all those changes into Thanos or to upstream those changes, or why not even forking an entire project you depend on. But at the very end, whenever we collaborate, whenever we share something, we also learn a lot. We learn a lot each other from successes and also from failures. We learned optimization techniques. We learned best practices. And at the end, all those learnings were invaluable. And we really, really got more from this collaboration than what we gave back. So to give you some practical examples, as we previously mentioned, we are building the Cortex block storage on top of Thanos, and specifically we are reusing the Thanos shipper, bucket store, and compactor, respectively in the Cortex ingester, the Cortex compactor, and the Cortex store gateway. And this allowed us to have a working solution in a way less time than compared to building all these features from scratch ourselves.
In the same time, as Thanos project, we are seeking into more ways into ensuring kind of quality, long-term quality of the project. And while we have other kind of our own framework, we seen kind of by accident that Marco developed on Cortex side kind of very simple but very powerful end-to-end framework based on Docker, which you can run from your Go tests. And it allows to run the whole stack, including many distributed system components, object storages, and databases within single machine, within multiple Dockers, without leaking any resources, any problems with the networking and deploying of those. And you can do that within the same kind of CI run. And we were totally passionate to kind of work together on this, use it immediately and adjust for kind of more library use. And this definitely helped us together to make sure we have high quality on both ends. And this was super, super useful. Another point that I kind of already mentioned is the query frontend, which parallelizes the queries made into to the backend. It was done primarily for Cortex usage. However, with Tom effort, we are able to use it on Thanos side as well. And there are a whole bunch of plans to improve that collaboration on this component. For example, Thanos plans to create a new component, which is Thanos query frontend, which will essentially embed and import directly the query frontend, just maybe with Thanos configuration on it, which makes it easy to reuse. So it's looking beautiful on that as well. One of the most major kind of improvements and contributions that kind of Cortex did to Thanos was, for example, shared caching. And you can do that via memcached support, which was added to Thanos. And it's not only about the client kind of shared cache that is separated into the in-memory cache that we were previously possible. It's also about caching finally different layers of data that you fetch from the object storage. Not only kind of index, but also chunks itself, so the compressed values that we have for each metric, and also metadata to limit kind of the S3 API traffic. And that's enormous benefit that kind of has to be done for Cortex needs, but also enormously help for Thanos community. So we could reuse, or we could essentially benefit both from that.
And Thanos has this very simple but effective DNS-based service discovery support, which we found very useful when working with Thanos. And we wanted to backport and reuse this service discovery mechanism into Cortex as well. And nowadays we are using it in the Cortex block storage, as well as for the memcached caching client. And now we currently have a PR open. We are adding the support for this DNS-based service discovery to the Gossip members discovery. Basically, the way we discover the nodes within a Cortex cluster running with the Gossip peer-to-peer protocol. And over the time, we have also shared many optimization techniques between the two projects in terms of CPU reduction or reduction of memory utilization, memory allocations. Just to give you an example, right now we are working to backport into Thanos the so-called YOLO string, which is a technique in Golang used to reduce the memory allocations, which we employed a long time ago in Cortex, and thanks to which we have seen a large benefit. And now we are doing the same improvements into Thanos as well. And at the end of this collaboration, we have also seen some optimizations upstream into Prometheus itself. And just to give you an example of how powerful is collaborating between different projects, in Grafana Loki, which is a solution for logging, we have learned about a technique to optimize specific use cases of regex matching. And we recently upstream into Prometheus an optimization to speed up labels regex matching with literal prefixes or suffixes. And now all the projects, Prometheus itself plus all the projects depending on Prometheus like Thanos and Cortex also has this optimization.
Yes, and it's not only about the features and optimizations that matters here. It's also about using the code much often and have more eyes on the same code base. Because with more activity, this code has more input, more feedback, and more possibilities to evolve, because code is living, and if you leave it dead for a long time, it will get obsolete very quickly. So just because Cortex we have additional users to our code base, we found massive amount of bugs and kind of fixes that were needed to be done, and even gaps in the documentation and things like that. So it was extremely helpful to just revisit a code, even as a reviewer, thanks to the contributions from our side. Maybe contributions that were aimed for Cortex mainly, however, still were touching our Thanos code base. And it's also not about the code itself, and it's not about technical stuff. It's also about feedback and ideas and just more developers. And we can clearly see that from our community meetings, where every project like Prometheus, Thanos, Cortex has its own kind of community meeting, but we kind of are all together in those free meetings, and we just talk about common problems and ideas, and help each other, and to push boundaries and even learn how to deal with problems around community or diversity or anything, to be honest. So it's extremely good to be transparent during project development, and kind of have critical maintainers meeting public, and allow contributions and collaborations like this. So at the end, there are key messages we want to share with this talk. First of all, open source is about people, about collaboration. It's about sharing and caring and giving back. And it's really better to team up with people and solve common problems, instead of trying to reinvent the wheel again and again. And even despite initial blockers and things to overcome, it's extremely valuable to essentially do things together, and because that's how things scale up. You cannot do everything alone within the same pace and velocity. And what it means in the future for us, especially for Prometheus ecosystem and Thanos and Cortex project, is that we don't have any reason to stop doing that, and stop doing even stronger collaboration in the near future, because one does not change a winning team, obviously. So that's it from our side. Thank you for listening to us. Feel free to ask questions on CNCF Slack, either Cortex or Thanos channels, and we are seeing you there. Thank you.
Thank you very much.
So welcome everyone, and I think we are happy to take some questions.
There's already something in the QA thing which you can click down below as a panelist.
Okay, I will mark the first question being live. So we have a question from Michael. Can we expect Cortex and Thanos to eventually merge into one project, given that both projects start converging on common code goal, the same as open telemetry? What do you think, Marco?
Well, that's a good question. We don't have any plan yet, but as we close the talk, this collaboration is working very well so far. So we don't have any reason to not continue collaborating. A few years ago, the two architectures were very different. Now they're getting closer, and with the block storage we're building into Cortex, we forced ourselves to speak the same store API of Thanos internally. So basically, even today, you can run a Cortex block storage cluster, and you can have esoterical setups like Thanos querying from both Thanos and Cortex and stuff like this. So basically, we are speaking the same API now, and this obviously will open up to a stronger integration between the two projects over the near future.
Yeah, I fully agree with all the things that Marco said. From my side, I would also mention that we don't want to push and force anything just because, I don't know, to merge from, I don't know, marketing side or whatever. We want to have this collaboration to go forward or stay or whatever naturally, and essentially just go in the direction where we can see benefit from both projects, and that's it. And let's see how it goes. Right now, it's getting closer and closer together, but yeah, whatever will work for both teams. And I think we have another question to you, Marco, specifically. Can you read out?
Yeah, Marco, you told recently joined the Cortex team. As far as I know, both projects are far from being called simple, and I agree. From your talk, I do understand that you have to learn both to contribute to one or maybe even three. I guess you mentioned Prometheus. Do you think that this would affect onboarding new contributors, especially open source contributors? That's a very good question. So the short answer is you don't need to understand every single bit of Prometheus, Thanos, and Cortex to start contributing. And I don't understand every single bit. Even in Cortex, there are specific Cortex components I've never worked on, which I'm not super familiar with. And the same happened with Prometheus and Thanos. I think that actually, on the contrary, reusing code simplifies, because many times without reusing it, we would end up rewriting the same things twice or three times. And on the contrary, reusing means that once you learned once, you know how it works in the three projects. If all three of them rely on the same code base.
Yeah, exactly. And I think the fact that some of the bits and components are reused across even 4 places, because you are also contributor to Loki, and we use some of things there as well, across Prometheus, Thanos, Cortex, and Loki, and so on. So yeah, I think this is also easier because it's still kind of the same ecosystem, the same similar characteristic, and the same code sometimes. So I hope it was easier because of that for you. Amazing. So we have a question now from Slack channel from Pericles. Where do those 2 projects compete in the end right now? So I guess, is there any competition, and in what level right now at the moment? That's a good question. I don't know. I can start. So, well, definitely there is some kind of competition in the form that people don't know what to choose from, and especially as those projects are evolving and having the similar features, it's hard to kind of choose from the end user which project to start with, especially if they are new and they want to just grab some long-term storage. So I can imagine this can be some kind of competition. So yeah, there is still some competition, but like we are believing that, you know, especially from Thanos side, I cannot speak for Cortex side. We believe that there is so many people needing that needs this kind of help in long-term storage and global view, whatever, that it's not the end of the world if half of the users will go to Cortex, especially that our storage format is actually compatible soon. So in my opinion, that's why collaboration is good here. There's like huge demand as well. Do you have anything to add, Mark, on that?
Not really. I guess, to be super honest, there's still a bit of competition in terms of query performances. But yeah, at the end of the day, once we found like a bottleneck in one of project, we immediately share it with the other project. So we catch up quite quickly on both sides as soon as we learn something new. Speaking about Cortex, to be super fair, the block storage, which is based on Thanos, is still competing hard with the chunk storage. I mean, making the block storage, the query performances of the block storage as fast as the chunk storage in Cortex is still a challenge for me and a few other people that's working on the block storage, because it's pretty fast and it scaled very well. But again, we see room for improvement, and I'm pretty comfortable saying that we are now quite close, and we may reach performance parity very soon.
Nice, amazing. We have 3 more questions, I guess. So Q&A question. What are the basic scenarios where one would choose Cortex instead of Thanos and Thanos instead of Cortex? Is there one rule fits all deployment or like project? I can start with this as well. So I think both can, you know, if you really want to, if you're, I don't know, really flexible, like both in some way can rule, one rule fits all, I would say. But let's say right now, the kind of suggestion we are making to the users, I think, is that where you have kind of simple use cases and you don't need that super, you know, high performance queries latency, you are definitely worth checking Thanos, and especially if you want to gradually install the kind of long-term storage and global view and all the features. However, you choose maybe Cortex if you have already multiple teams working that has to work on the same centralized, let's say, data. Cortex has already nice multi-tenancy features, and Thanos is only catching up right now. And also there is like high priority on high performance queries. So since everything is centralized from the very beginning and scratch and design, and there are lots of caches, caching layers more than even Thanos, you might want to choose that one. However, there is some complexity on the way. That would be my kind of quick glance, but again, the things are changing. Anything else, Marco? If not, can
I agree with what you shared.
Okay, so Yash is asking, how do you approach to working on a code base which you aren't familiar with? More like habits and steps which you have cultivated for approaching new code base. Maybe Marco.
Right. So how do you approach working on a code base which you're not familiar? Start simple and focus on one single problem to solve. Even if you look at, I mean, desk systems look complicated from, or may look complicated at first sight from an architectural perspective, but when you go deeper into a single component, they're actually pretty straightforward, the way it works. So my suggestion is to, well, you usually start approaching a code base with a reason, like you want to improve something or you want to fix a bug. Just keep focus on it. And then your knowledge will grow as more as you contribute with the project, but don't expect to learn everything immediately. It will not happen. It doesn't happen to anyone, but this shouldn't scare you. And don't be scared to submit contributions, even if they are in a draft state. Like you're getting close to something, but you get test failing and you don't understand why, or you are blocked on something. Open a PR, open a draft PR, or join on the Cortex or Thanos Slack channels. Ask for help. We are here to help, and we are here to also guide you if you need any help with first-time contributions.
Yeah, I definitely want to highlight especially the part of being blocked and not saying anything. Just talk to people and try to push and submit something. And there are very often the case that the reviewers will point you in the right direction and explain maybe one thing that you cannot or you are confused with. So definitely collaborate is the answer, but also, yeah, be patient and try to understand the code base. Fortunately, we all program in Go, especially in this ecosystem, which is using roughly the same consistent style guide. So we are kind of better than other ecosystem, I hope, for this particular part. Okay, any other question? I think we have kind of last on chat that was actually already answered. It was about strong points from each of project. We kind of covered that, I think, with the previous answer. If not, then thank you for listening to us. Yeah, Richie?
Are you ignoring the question on Slack?
Yes.
Okay, good.
I unless you want to explain that.
No, it's fine.
No, okay.
No, everyone who's not on Slack is wondering what we're talking about, but that's fine. You should be on Slack and making bad and good comments about the content along with us. Thank you very much. Thank you very much.